Here's a video about domain and range and how we will have the notation be this year. So domain and range. Domain and range are just kind of describing a graph and describing how far left and right the graph goes and how far up and down the graph goes. So domain is going to be for our x values, which means left and right. So how far the graph goes to the left and the right. Does it stop or does it continue forever? The range is going to be for the y values, which is our height. Okay, so how far up and down the graph goes vertically. Okay? And what we're going to try to write is, there's a couple ways that you may see domain and range written throughout the year. One way, the most basic way, is say it goes from 0 to 5. Okay? That's very basic, and a lot of people should be able to understand that notation right there. Just written, if it goes from 0 to 5, if that's the direction it goes, 0 to 5 on the graph, then that's how you could write it. But we're going to also write this a little bit differently with a fancier kind of notation. Alright, so we're going to use some inequality signs. And what we're going to do with that is, in general, we're always going to write a little phrase here that my teacher used to say. We're going to take the smaller number and then a less than the variable. This should all go on one line. It doesn't have enough room. The smaller number less than the variable, and then another less than sign, the larger number. And then all you need to figure out is if it is including the number. If it includes 0, we would put a line under here. If it does not include a 0, we would not have the bar under the less than sign, right? So it would be a less than or equal to sign as the choices. So that's going to be our phrase. So in this case, I'd say if they include both 0 and 5, we're going to have some examples with pictures. I would say 0, because that's the smaller number, less than, I'm pretending that includes 0, and then the variable. For domain, let's say this is for domain, it would be an x, would be our variable. And then less than or equal to the larger number. So that's how we would describe the domain. So you might see your teacher writing it like this. You might see them using some parentheses instead of the inequality sign, so make sure you ask them, but in general, also describing it like this as well is acceptable. So let's do some examples now. So here we have a graph, and domain, remember, is x, and that's left and right. So we want to look at what is the leftmost part of this curve, not the actual grid itself. I want to know on the curve. So on this curve, what is the leftmost point? Well, the leftmost point is right here at 1, 2, 3, 4, at -4. And then we're going to say it goes up until -1. So if I'm going to use, let's do this. So it goes from this distance right here all the way over to +1. That would be my domain, or all the possible x values. Okay, it goes from -1 or -4 to -1. So if we want to write this with the inequality symbols, we're going to write the smaller number, which happens to be -4. Less than, does it include -4? Yes, there was a dot there, so it included -4. The variable for domain is x. Less than or equal to the larger number, which is still negative, but that's okay. So that's one way to possibly write it. Let's look at the range now. The range is the height. So I'm going to look at the lowest number, which is this direction at -2, and then it goes all the way up to +2. Now we don't want just this point right here because it continues higher than that. So we're going to say it goes from -2 as the lowest up and down, and this is with the variable y, and then it goes up to +2. So I'm looking at the height of the curve on my graph. So if I use the inequality notation, I'm going to write the smaller number, less than the variable, less than the larger number. Oops, caught myself here. This needs to be a y. That's a really important thing. A lot of you are going to mess that up, and see, even I did that. So one last thing is we need to give these both equal to signs, because there are points that hit at -2 and at +2 in the vertical direction. We'll see a little bit later on where it does not include some things. Let's look at another example. So domain again is x, which is left and right. Pretty bad looking arrow. So we're going to look at how far it goes to the left and right. So look here on our graph, we have these arrows. This is a different type of graph. I have some arrows. The arrows are going to continue up forever and outward forever. So out towards like this direction forever. A little bit every time. So the leftmost part of this curve, well, it's currently right around here, but this is going to continue going up and out forever and ever. Same thing over here. It's going to go up and out forever and ever. So actually our domain, there is no smallest or largest number left to right. So we could say a couple of different ways. You could say all real numbers. I'm going to be lazy and just write numbers there. You could write this symbol, which also means all real numbers. Or you might write, if I use the inequalities, I can write negative infinity less than x less than positive infinity. I want to specify positive and negative infinity because that tells me the different directions. And I can never actually equal infinity or negative infinity, so I do not have the equal to symbols in my inequality signs. So those are a couple ways you can write that domain. Now the range is the y values, which is up and down. So let's look at our lowest value, which is right here. That's the lowest part on our curve, which is at -6. And it goes to, well, it keeps going up and up forever and ever. So I'm going to say to infinity. Okay, now if I use the inequality notation, I have the smaller number, less than the variable is y, less than the larger number. So I can include the -6 because my graph hits -6. But again, I cannot ever reach a positive or negative infinity, so I'm not going to have the symbol underneath that one. Okay, so let's look at one more example of domain and range. Domain again is x, which is left and right. So we're going to look the direction. These are supposed to be arrows here that continue forever both ways. All right, now what we want to look at, what is the leftmost value on our graph? Well, this has an arrow that keeps going forever and ever. This side has an arrow that keeps going forever and ever. So it would look like, since it continues both outwards in both directions forever, that it would be all real numbers again, except what this is doing is there's something called an asymptote right here, which means it's never allowed to hit when x is worth 0. So I want to say my domain could be all real numbers, except x cannot equal 0. Okay? So it is basically everything. It's easier to say it can be everything except one number rather than you can't possibly list every other number besides 0 because there's infinitely many. So you could also write this if we're using our other notation. I would do the same exact thing as before and just say x cannot equal 0 on the side. That's very important. So that's called an asymptote. So the range we're going to look at is our up and down height, which is the variable with y. So we're going to look at, again, we have like a lowest point right here as of now, but it's continuing down forever. This is continuing up forever. Now the only place it never hits is right around here, when y is worth 0. So we have two asymptotes in this graph. And so I'm going to say my range, again, I could say all real numbers here. That r just means all real numbers, except y is not allowed to equal 0. So we could write it like that. We could write it with our inequality symbols. Same thing, I can never equal an infinity. And I just need to say y is not allowed to equal 0. So either way you say that, you could write out the words again, all real numbers, but that's when you have an asymptote, you're going to have things that the domain and range cannot equal. So you need to talk about that. So domain again is x, range is y. Make sure you know this concept. Ask your teacher if you're still having questions.